So what I have going on here is a resistor, which is this, and a capacitor hooked up in a parallel circuit. You can tell that there's parallel because each of these two leads share the same row. And then what I have going from the bottom of one of the rows, if I have connected through a 220 resistor, this protects the pin going into pin 0. So with this pin, I can set it to high, which will energize the capacitor. And then on the other end of the RC circuit, I have it connected to ground. So ideally with this RC circuit, what I'm going to do is charge it up, and then I'm going to cut off the power by changing this to low. And then what I can do is time how long it takes from this to go from 5 volts to 1.4 volts. Any voltage between 5 and 1.4, the pin considers as being on or 1. Because it's a binary pin, all it can report out is a 1 or a 0. Any voltage between 1.4 and 0 volts, it considers as an off switch. So on is from 5 to 1.4 volts, and off is from 1.4 volts to 0 volts. Okay, at 1.4 you get this transitional zone, and you never want to really measure there. So how do I do all this? I run it, of course, with the code. So key things to remember again is notice how these pins are in the same rows here. So therefore this capacitor and this resistor is connected in parallel. Here's my resistor. Brown is 1, black is 0, and red should be 1,000. So this should be a 1,000 resistor. Okay. So I come to my code, and so the first thing I'm going to do is charge up my port. I'm going to set it to high. That's why you see that high 0. And then I'm going to wait 1,000 milliseconds. That gives me time to fill up my capacitor. So I can fill it up in 1,000th of a millisecond. I can even figure that out mathematically using a thing called my rise time. And then my rise time is going to be what my capacitor is times the value of my resistor. So this capacitor is a 0.1 microfarads capacitor, or 0.1 times 10 to the negative 6, right? And then I can multiply that by 1,000. Okay, and so that's how it tells me how long I should take. We'll call that the tau, or the RC. So tau is equal to R times C. So I'm trying to skip the math of this. So what I want this pause to be, this pause is going to allow me to charge up. So what I want that pause to be, at least to be 5 times the number in seconds of R times C. But for the most part, always pretty much, for now, with you guys, for this type of circuit, you can always put in 100. And to solve this math problem, it takes a little bit of calculus and an understanding of exponentials and logarithms. Then this next line says, hey, it's RC time. RC time is a reserve word. And so we start here and say, hey, look, monitor pin 0. And pin 0 is going to start in a fully charged state. That's what that 1's going to be. Here it can also be a 0. And in this D time, it says, hey, look at pin 0 and tell me how long does it take to start at a 1 and transition to a 0. And we're going to store that value in the variable called D time. And I call it D time because it's just discharge time. And then what it's going to do is print that out to the screen. So I upload that to the computer and run it. And so D time is equal to 52. And 52 what? So these are units of 2 microseconds. So these are 52 2 microseconds, right? But for most application purposes, you just got to know that value is 52, okay? So now what will happen to that value? I got this teeny tiny little capacitor there. What if I go and get a bigger capacitor? What if I plug this in? I think this capacitor could be 10 to 100 times bigger. So what I'm going to do is plug this capacitor in and run the test again and see what will happen.